All right, so today we're going to learn how to calculate the percent composition. So what that means is if we look at a compound, we're looking at what percent of the compound is the first element, what percent of the compound is the second element, what percent is the third element, and so on. When we talk about the percent composition, we're talking about the percent composition by mass. Okay, so when we look at a compound, what percentage of it is like the mass of one element, what percent is the mass of another element, and so on. Okay. So for the definition, you can just write what I have bolded. So when we talk about percent composition, it's the relative amounts of elements in a compound by their mass. And then in addition to getting our bolded definition, go ahead and copy our formula down here. So in order to calculate percent composition, we're just going to follow this generic formula. So we take the mass of whatever element we're interested in, and we'll divide it by the mass of the entire compound. And then to turn it into a percent, we multiply it by 100%. So get the definition and get this equation down. All right, so to learn how to calculate the percent composition, we're just going to do a couple practice problems together. Each one is like a little different, like maybe a little different wording, just so you can be familiar with types of problems we'll see. So for this first one, we have an 8.20 gram piece of magnesium, and it combines with 5.40 grams of oxygen. What's the percent composition of this compound? Okay. So what that's asking is, of this magnesium oxide compound, what percentage of it is magnesium, and then what percent is oxygen? So the first thing we need to figure out is just the total mass. Okay. Are you given some numbers in the word problem where we could find the total mass? Okay. So how can we get the total mass? What two numbers can we add together? 8.20 plus that 5.40. So what's the sum of those two numbers? Good. All right, so our sum is 13.60 grams. All right, so now to figure out the percent composition, we find it for each element. It doesn't matter if you start with magnesium or oxygen. I'm going to start with magnesium just since it's listed first. Okay. And I'm just going to use the equation that we wrote down on the previous slide. So we're going to take the mass of magnesium divided by the total mass. Okay. So how much magnesium is in this sample? Okay, so our mass of magnesium is 8.20. And we're going to divide it by the total mass, which is 13.60. And then we'll multiply it by 100 to turn it into a percent. Okay. So go ahead and get out your calculator. Type this in. Make sure you can type it in correct to get the correct answer. If you're struggling, you might need to put parentheses around the numbers you're going to divide and then multiply it by 100.
Why did we put 8.20 on top?
It's the mass of magnesium, which we're pulling from the word problem. Okay, what are we getting? Do we have a number?
60.29.
Okay, Jill agrees 60.29%. Is anyone else getting that? Like we're in the 60? Good. Okay, 60.29% magnesium. All right, and then what's the other element in this compound?
Oxygen.
Okay, oxygen. So now we're going to do the same thing for oxygen, except this time we use oxygen's mass. How much oxygen was in this sample? Okay, so 5.40, which I'm grabbing just from the word problem. And we're going to divide it by the total, 13.60, and then we'll multiply by 100. Are you getting 39 something?
Yes.
Okay, what are you getting?
39.71.
Okay, 39.71% oxygen. Okay, good. Now, what can you do to check your answers?
Add them up.
Add them up. What should they add up to? Okay, they should add up to 100. Is it okay if you're close, like 99.9, 99.8? Sure. You need to be very, very close to 100, though.
What if you're over it?
If you're like 100.1, it's okay. But if you're like 105, go back. Check your numbers. All right, now we're going to calculate the percent composition of propane, which is C3H8. This one is a little different because there's no numbers. You with me how this one looks different? Okay, so if there's no numbers provided, you're going to use the masses on the periodic table.
Yes.
Okay? So the first thing we need to get is just the total mass. So C3H8, we're just going to get the molar mass. I'm going to go slow on this one. So how many carbons are in this compound? Okay, 3. What's the mass of carbon? 12.01. That comes straight from the periodic table. And then I'm going to add that to hydrogen. How many hydrogens are in this compound? 8. What's the mass of hydrogen? Okay, so go ahead and add those up. All right, what are we getting? 44.11. Okay, 44.11?
Yeah.
Good. Okay, so now we're going to get the percent of carbon and then the percent of hydrogen. So I just start with the first one listed. Okay. How many total carbons are in propane?
3.
Okay, so there's 3. So that means you have to take 3 times carbon's mass. Okay. So what's 3 times 12.01? Okay, so carbon's total mass, 36.03. Okay, so then we're going to take carbon's mass divided by the total mass times 100. $81.68 carbon. Do you agree? Do multiple people get 81.68? Check. Yeah, okay, you should be getting 81.68. Okay, what's the other element in this compound? Hydrogen. So then now we're going to do the same thing for hydrogen. We're going to get the mass of hydrogen. How many hydrogens are in this compound? Okay, so make sure you multiply hydrogen's mass times 8. So what's 8 times 1.01? Good. Okay, so we'll take the total mass of hydrogen, which is 8.08, and divide it by the total mass of the compound, and multiply it by 100. We should be getting 18 something. Okay, what are we getting? 18.32%. Okay, and then how do we check our answer to know that we didn't make a mistake? Add them. What should they add up to? Good. All right, so now this one is an extension from the previous problem. Okay, so calculate the mass of carbon in an 82.0 gram sample of propane. Questions like these are probably the most real world applicable. Think about let's say we wanted to recover a metal ore in the ground. We need to know let's say we have a bunch of ore down there and we want to pull iron from it. Is it important that we know how much iron we're going to get to make sure we'd be profitable? Okay, can you stay in business if you lose money? No. So this is really in chemistry, this is mainly why we care about percent composition. Okay, so we want to know how much of a sample can we grab of something valuable. So we're going to figure out how much carbon can you get from an 82.0 gram sample of propane. Okay. This goes straight off the previous problem. In order to answer this, you have to know what's the percent of carbon. So look at your answer from the previous problem. What percent of propane is carbon? Okay, so you have to get that number first. Okay, so if you don't have the number, you have to find that number. Okay. So then now we know in propane, 81.68% of it is carbon. So then we just need to figure out what's 81.68% of 82 grams. Okay, so to do this, you need to convert your percent to a decimal. So change this to a decimal. How can you change your percents to decimals? Like to decimal form?
Divided by 100.
Okay, so you can divide it by 100. So 81.68 divided by 100 becomes 0.8168. Is there another way that you don't have to use a calculator?
Just move the point to the left twice.
Okay, you can also move your decimal 2 to the left. Okay. So then to figure out 81.68% of 82, we're just going to take 82.0 grams. And you're going to multiply it by the decimal form of that percent. So multiply it by 0.8168. And that'll tell you what's 81.68% of 82. So if you multiply those numbers, what do you end up getting?
66.9776.
Okay, 66.977. We'll round. When we do percent composition, sig figs can be a little tricky. However, when you get to this part, like your final answer, how many sig figs are in 82.0? 3. So how many should we have in this answer? 3. So what should we round this to? Okay, so it becomes 67.0 grams of carbon. And then if you want, the trickiest part of this is just make sure you multiply by the decimal form of that percent. Okay, so if you need to write yourself a little note, like that's the only tricky part. Make sure you change your percent back into a decimal. All right, so now we're going to find the percent composition of KMNO4. So what's the first thing you need to do? What are we going to find first? Okay, we got to get the total mass or the molar mass of KMNO4. Give me a thumbs up if like you're like, Ms. Wilcox, I got this, I can do this. Thumbs down is like, don't even know where to start. Okay, thumbs in the middle is like, I'm willing to try. Okay, good. I want you to try to get the molar mass by yourself. Use the masses from the periodic table. Anyone have a number for molar mass for KMNO4? 158.04. Do you all agree? Okay. And then next we're going to figure out the percent of each different element in the compound. How many different elements are in KMNO4?
3.
Okay, 3. How do you know?
KMNO.
But how can you distinguish them? What are you looking for?
Capitals.
Good. Capital letters. Okay. So we'll just, I go in order. Okay. So potassium. How many potassiums are in KMNO4? Just 1. So what's the mass of 1 potassium? Good. 39.10. That number comes straight from the periodic table. Okay. So then we take the mass of potassium, divide it by the total mass, and multiply by 100. Does anyone have a percent for this part? 24.7. Do y'all agree? Okay. Next is the manganese. How many manganese atoms are in this compound? Okay, just 1. So manganese has a mass of 54.94. Again, that number comes straight off the periodic table. We divide by the total mass, 158.04, and then multiply by 100. Does anyone have this number already?
34.76.
Okay, 34.76. And then last is oxygen. How many oxygen atoms are in the compound?
4.
Okay, so what do you have to do with oxygen's mass? Okay, so make sure you multiply 16 by 4. So what does that equal?
64.
Okay, so then oxygen is 64 divided by the total mass times 100.
49.
Okay, 40.49.
Yep.
Okay, do y'all agree? Okay, if we add them up, what should they add up to? Really close to 100, yes? Good. All right, our last question that we'll work on today is how much iron can be recovered from 25.0 grams of iron 3 oxide? So this one, we're just looking for like a gram. So how many grams of iron can we grab from this sample? Okay. So the first thing we need to know is we have to know the percent composition of iron. Okay. So you have to know the percent composition of iron before you can move forward. Okay. So then in order to figure out the percent composition of iron, what do we have to do with Fe2O3? What do you have to figure out? The total mass. Good. Okay, so use your periodic table to figure out the molar mass of Fe2O3. Does anyone have a molar mass for Fe2O3?
159.687.
Okay, 159.
Yeah.
687. Okay. Thank you. Do you all agree? Okay. All right, so now what element are we interested in getting the percent composition of? Just iron. Do we care about the oxygen? Okay, no. Do you have to waste your time finding the percent composition of oxygen? No. Okay, we are only interested in iron. How many iron atoms are in that compound? Okay, 2. So make sure you take 2 times the mass of iron. Okay, so what's 2 times 55.85? What do you have?
111.
Okay, so we get 111.7. We'll divide that by the total mass. And then we'll multiply it by 100. What are we getting?
69.94%.
Okay, 69.94%. Do y'all agree? Okay, so now that we know the percent of iron, now we can just multiply it by that 25.0 grams. Okay. So we know iron's going to be 69.94% of 25. What do you have to do to your percent before you multiply it? Okay, and how do you turn it back into a decimal?
You just move the decimal point in front of the first one.
Good. Just move the decimal point 2 to the left. Okay. So then we'll take 25.0 times 0.6994. And what do we get?
17.5 after sig figs.
Okay, 17.5. Good. And it's going to be grams of iron.